They make it incredibly easy to introduce bugs, and they incredibly difficult to debug. So that's one real issue with the language. Next one, scope. So scope is all about where you define your variables. You define your variable and you'd expect it to have a lifetime within a particular scope. So JavaScript's got this block syntax that you know from languages like C and Java. In languages like C and Java, whenever you open a block, any variables that you create within that block are restricted to being accessed within that block. That's a fundamental tenet of those languages. In JavaScript, because JavaScript has to be a little bit different, there are only two scopes. There is function scope and there is a global scope, and that's it. Irrespective of how many levels of squiggly braces you have, there is only two scopes. So take, for example, this code example. Function bar, it has a variable called a set to 1. It's got if statement, which opens what you'd expect to be a new scope in most languages, sets the variable b to 1. This variable b, its scope is not within the if statement, it's scoped at the function level. So after that if statement's evaluated, you can still access the variable that was created within it. So in this case, this function returns a plus b, it would return 2. Again, this is a major source of confusion with the language. What about something like this? So a lot of you will have written for loops in C and Java, where you say for int some variable equals some number, some variable is less than some value, that variable is. Really complicated thing. You normally, if you're doing this, you'd declare the variable, it would only exist within that for loop. You would never expect it to have values outside. Well, in JavaScript, it does. So even if you put the var keyword inside the declaration of the for loop, the variable that you've created for the iterator is available in the function scope that created it, or even the global scope, depending on how you did it. Implied variables come into play here as well. If you didn't ever declare what the value you're using in the for loop is, if you didn't ever put a var keyword in there, then you'd actually create a global variable. And again, that leads to interesting bugs that are really hard to find. What about this one then? So JavaScript was written, and when it was created, it was written to enable script keys to be able to program. Okay, so it wasn't designed, well, it wasn't aimed at people who are good at programming, it was aimed at the general kinds of people who are writing web pages. So in order to make it easier for those people to write JavaScript that would run within the web browser, the interpreters that were originally specified were very lenient about the syntax of the language. So the syntax specifies that every statement ends with a semicolon, just like you'd find in C and in Java. However, the interpreter's lenient, and it'll work if you miss the semicolon. And in fact, what it does behind the scenes is follow a set of rules to automatically insert the semicolon where it thinks you meant it to be. Whatever you do, don't ever use this. Let's look at why. Here's an example. There's a function called foo. It returns hello world. What does it? Does anyone like to hazard a guess as to what will happen if we call this function? What's the value that's returned by this foo function going to be?
What the equivalent of void is.
Yeah, exactly that. Undefined. Let me show you.
Yeah.
I just switch to the terminal. Can you just about read that? So I've typed the function into the node interpreter. I call it hello world in this case, rather than foo. But you see it says return new line hello world. If I call hello world, so the result is undefined. Why is this? Why is the result not the string hello world? That's what we wanted it to be, that's what we're expecting it to be. Well, here's a hint. the interpreter sees that there's a return statement, but there's no semicolon. So it applies its magic and says, the program has made a mistake. They missed a semicolon. We'll put the semicolon right here. It's completely insane. Okay, it makes no sense. But that's how it works. So whatever you do, be really careful about those semicolons. Okay? Just because the language doesn't necessarily need them, if you don't use them, you're going to run into all sorts of problems. Okay, next one, typos. So we looked at the typos operator last time, and we kind of saw some of its weaknesses. You can say typo and give it an argument, it'll return its type. So, what happens if you do different things? Well, what's the type of null? It's an object. What's the type of /a/? That's actually a JavaScript way of writing regular expressions. You can write them between a pair of slashes. Well, this depends. Depends on what JavaScript engine you use. It might be an object, it might be a function. Depends on the implementation. What about an array? Well, the type of an array is an object, of course. But we saw last time that the type of a function is function. So it's not very consistent. Reserve words. We kind of mentioned this last time as well. That when the language was first created, it took all of the reserved words from C and from Java and said, right, you can't use this. Even though they didn't have any places in the language itself. Things have improved with the newer standards, because obviously without breaking backward compatibility, you can reduce the set of reserved words if you're not going to use them. But there are still a relatively large set of reserved words you have to be careful about. Some of them, class, static, super short hints, they have no place in the JavaScript language, we're not allowed to use them. You can't use these things to name variables, so it's illegal to create a variable class, for example. You can use them as object properties if you're careful. It's illegal. In this case, in these examples, we're trying to use the word case as the property name. It's illegal to define an object in JSON like this with case colon values. But if you quote it as a string, it's perfectly legal. You can't use the dot notation, that's illegal, but you can use the quoted notation with the square bracket. So it is possible to do these things, but you just have to be really careful about it. The addition operator. How does that behave? Well, we saw already that it's overlaid. We saw that you can do things like add two strings together. We saw that WAP video where there was some example shown. So we got the first one, string plus string, gives you a string. That's alright. Concatenate two strings. Number plus number gives you a number. And that's probably okay. Any other type? It really depends. Array plus array, empty string. Well, that was an empty array. Arrays with numbers in it. So an array of 1, 2, and an array with 3 and 4 in it. That gives you a string. At least it's consistent. Doesn't make any sense whatsoever. Array plus object. Depends on the JavaScript engine. Even today. So if you run it in Node, but it give you an object, or give you a string because it was an object. So this is actually a string. If you run it in JavaScript core, it gives you 0. Because again, that makes total sense. Object plus object. Well, that gives you the string that says object, 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 object. Or if you run in the JavaScript core, it gives you not a number. Because again, that makes total sense. So these things are really poorly defined. Okay, so they're the really, really awful bits of language. They're the things that are going to trip you up, because they're completely different to how you expect them to behave. Basically, there are no sane decisions in those bits of language. So there are some bad bits, which are maybe not as bad, but they're still interesting. For the observant of you, who have been paying attention to the last 3 lectures, you'll notice that on all of my examples in the slides, where we've had an equality test, we've always used 3 equal signs. Anyone like to say why?
Because two equals will allow type coercion, whereas triple equals won't allow it.
Yeah, precisely. That's exactly the right answer. Basically, the two equals and the bang equals, they're, well, this is what the JavaScript good bit called the evil twins, because they do weird things with types. Let me give you some examples. So these equal twin operators, they do random things with types. So let's look at some examples. So an empty string equals the string 0, false. Okay, I think we can be happy with that one. But 0 equals the empty string. True. What? No sense. 0 equals the string. So the number 0 equals the string 0. True. Okay, you can kind of get your head around that to see why that might be the case, but it's still a bit weird because you're comparing two completely different types, and they're being returned as being equal even though they're completely different. False equals the string false. Well, that was false. That's interesting. But false equals the string 0. True. What? Makes no sense. False equals undefined. False. Okay, that's good. False is equal to null. That's also good. That's false. But null equals undefined. True. What? They're completely different things. They have completely different meanings in the language. It makes no sense. Well, the last one. Space, tab, carriage return, new line, space, equals 0. True. Of course it does. You know, it's a string full of characters. It's equal to 0. These things are weird. They behave in completely strange ways. So the best advice I can give you: don't ever use a double equals or a bang equals. Always use the other variant. Always use 3 equals or bang equals for the not equal variant. The reason being, they will behave like you expect them to do. They will look at the types of the object, and they will take those types into account when they're doing a comparison, and they won't do weird casting. Okay, eval. So every JavaScript environment has something called eval built into it. Eval takes a string, which has got some JavaScript code, and it runs that code. Sometimes this can be really useful. Maybe you want to run some code somewhere else in the string. That demo that I showed you was the computer vision demo, that you type some code into a box, and it ran that code and did some image processing. It uses eval. That's a reasonable use of eval. But beyond that, beyond those kinds of use cases, you should never ever use it. Why? Well, it's slow, and it's a massive security risk, because it potentially enables your code to run someone else's code. And if they've got control over, if it's possible for the user to inject code into your code, they can change things, they can change the way it works. So potentially they could steal information, they could break into your application, they could break your application. So try and avoid it, but there are cases where it's useful. Okay, interesting bits of the language. So globals are bad, and JavaScript is based around globals. But the way that it does it is a little bit interesting. So JavaScript, the JavaScript environment is based around a thing called the global object. And anything that you declare, so any variable that you declare that's global, or any function that you declare that's global, becomes automatically a property of this global object. This has some interesting implications. So it means that any JavaScript runtime, irrespective of whether it's Node, whether it's in a web browser, whether it's running on a TV, any JavaScript runtime has a global object. Those global objects are all different, but they exist. And you can alter them. You can add properties to them by creating global variables. the default set of variables that are available for you to use in whatever environment you are using, they are properties of the global object, or they're methods of the global object. All of the functions that are available to you by default within whatever environment you're using, they are methods of this global object. This means that any JavaScript environment is completely defined by its global object. So different runtime environment, Node, web browser, TV, whatever, they're all basically the same JavaScript engine, but they've all got different global objects. And those global objects are what enable you to actually do things that are useful. In a web browser, the global object actually has a name. It's called window. And interestingly, it has a property called window which points to itself. So whenever you're writing JavaScript on a web page, you can refer to a variable called window, a global variable called window, which is the global object. This means that it's really easy to, irrespective of what scope you're in, you can always refer to the global object explicitly. Okay. Why is this elegant? Well, I think as I already said, different environments, the global object is different, but everything else is the same. And this is really quite powerful. Okay. So we already, last time we looked at some of the functional features of the language. The fact that functions are first-class objects. You can pass functions around. This enables you to do functional programming. The functional scope is interesting though, because what it means is that variables that are created within a function will obviously belong within that function, but they can escape. And here's an example. So this is a function called getName, which defines a variable called name John. Inside that, it has another function, so that's called innerGetName. That innerGetName function is obviously scoped at the getName function level. So it's basically a variable within that function. InnerGetName though returns name, so it's returning something in the outer scope. And this is fine. JavaScript will do this. So getName at the last line of it says return innerGetName. So if we call getName, the result will be John. Logically, this all makes sense. This enables you to do some really interesting things. So even though, the point here is that even though that variable name is declared within the function scope, it's available for anything else within that same scope. And the inner function has access to all of its variables and the enclosing scope. Why is this useful? Well, it enables you to do things called closures. So in this closure example, as like in the other case, we've got a slightly different variant here. Instead of returning innerGetName brackets, so instead of calling the function, we're actually returning the function. So this is a getName is now a function that returns a function. Func, so down here, is going to be actually set to the function, and we can call that and it will return John. So just as before, but rather than a convoluted way of returning a string, you've now got a function that returns a function which returns a string. Right. There's a catch. There's always a catch with JavaScript. When you create these nested functions, when you create these closures, the variables, the values of the variables, are set when the outer function exists, not when the inner function is created or declared. So here's an interesting example. A function called func sets a variable I to 0. It's got an inner function called inner, which returns I. I is then incremented, and the function func returns the inner function. If you call this function, the result will be 1. Even though the inner function, which was returning I, the value of I when that inner function was created would have been 0. Okay, so what's happening is that a variable is getting incremented and then it's getting returned. It's not that it gets returned in the order of the order that the code's written. So it can be a little bit surprising. Okay, you write the code in one way, but it's not necessarily what it does.
Why do you have two sets of parentheses on the...
Because the first one calls func, which returns a function, you've got to call that function. Okay? I should note that rarely are you ever going to write code as dumb as this. I mean, these are contrived examples, just to sort of show how it works. Kind of advise you didn't do things like this. What you will be doing is things like this. So this is a really common programming mistake in JavaScript, and it will leave you scratching your head for hours. So one thing that you quite often do when you're programming HTML web pages is maybe you've got a series of elements in your web page and you want an auto-response click, for example. So you might have I think an on-click handler that responds when you click on something. So when you click on an item on the web page, a piece of JavaScript, JavaScript function gets called. A common way of doing this would be to have a function, say like this, that's called add handlers, and you give it some nodes, so they're the things in the web page. In this case, we're basically got a for loop, so we're going to loop through all of the things in the web page that we want to add the click handler to. Nodes is an array, so we can index it with a variable I. To each node, we're going to add the on-click handler, we're going to add a new function, and we're asking it to alert in the web browser for a little dialog box, and it will say whatever the string was passed to was. So what we'd be expecting here is that let's assume that we've got a pile of say we've got a list of buttons in a web page. We'd expect that if you click the first button, it would say 0, it would pop the dialog box with 0. Click the second button, it would pop up the dialog box that says 1, so on and so forth. Is that what's going to happen in this code? Anyone? What do you think is going to happen? Okay, so I'll tell you. All of those dialog boxes are going to print, those alert dialog boxes are going to print the same variable. They're all going to print the I will be set to nodes.length, it'll be its last value. Every single one of them is the same. That's clearly not what we intended to happen. There is a solution to this. The solution to this is to essentially create an extra function. So we nest more functions. Create a helper function that creates essentially a new scope. And by doing so, captures the value that we want to be able to print. So our new version of add handlers has a helper function which takes in a parameter j. Inside that, it returns a function which alerts j. Then we loop through all of our nodes as before, but rather than creating the function and assigning it in place, we use the helper to generate the function for us. And by doing it this way, we're essentially creating a copy of each of those variables. So the I variable in this loop, when you pass it to helper as a parameter, a copy of it is made and saved. And this will have the desired effect. So when we have our buttons, that button will print 0, one print 1, so on and so forth. Okay. At this point, are there any questions? So I think I've covered the key bits of JavaScript language you need to be aware of. A lot of these you need to go away and just try them. Just look at the slides that are online, copy the code out and paste it into Node or JavaScript Core or your favorite JavaScript engine, and just see what happens, and just to understand how the language works and ways, and the ways in which it doesn't work the way that you expect it to. For the last 15 minutes, I want to tell you a little bit about how to write good JavaScript. This is important because it's get to as much in the coursework. So in both of the coursework, we're going to look at code, and you'll be assessed on the code that you write. So you might as well know how to get high marks. So first of all, stylistic issues. Consistently coding is, or coding style is important in all languages. If you've ever written some Python code, and in some places use spaces and in other places use tabs, you know what I mean. JavaScript is no exception. Actually, it's true of any dynamic language. So any language where there are is loosely typed or completely dynamically typed, particularly true. JavaScript throws errors because the syntax is very loose compared to the languages that you're normally used to. Errors are really easy to make. There are no compiler errors. There is no compiler. It runs when you kick the code off in whatever environment you're running. So it will fail at runtime. Failing at runtime is bad because the user who's using your application will see an error. And you didn't know about it. How can you get around this? Well, a clear and consistent style can help mitigate some of the problems. There's a few things that you can do. First of all, code commenting. Now, it's been hammered into you time and time again that you need to comment your code. In JavaScript, you need to be especially careful, particularly when it comes to documenting what types of functions that you write, or functions or methods that you write. When you declare a function, you can specify what the parameters are, but there's nothing in the language that defines the types of those parameters. So you write your code expecting the parameters to be a Boolean and an object. Anyone using your function can pass whatever they want in because there's no contractual type constraints. So you need to document. You need to document every parameter to say exactly what you're expecting it to be. So comments are really, really important for that. Because there's no compiler, you don't get errors, but there are some useful tools. So there are tools that do static analysis. So static analysis is basically what a compiler does before it compiles the code. It parses the code, runs it through the Alexa, and then says, well, this doesn't conform to the syntax. There are basically syntax checkers, static analysis tools for JavaScript. And you should use them. So some things that you should consider, some tools that you consider, there are 3 really good tools. JSLint, JSHint, and JSCheck. So these are all static analysis tools for JavaScript code. They look at your code and they code what's wrong with it. I'll give you some examples of that. These tools are all different, so they've all got pros and cons. We'll focus on JSHint and JSLint. JSLint was pretty much the granddaddy of these tools. It was written by Douglas Crockford, the guy that wrote that JavaScript book that I showed you in the first lecture. Unfortunately, or perhaps fortunately, it's designed so that it makes you write your JavaScript code in exactly the way that Douglas Crockford writes his JavaScript code. Down to whether you use spaces or tabs, down to exactly what line you put the semicolon on, down to the way that you name variables. Okay? So if you want to write like Douglas Crockford, use JSLint, and it will force you into his coding style. If you want to adopt your own coding style, which is totally fine, there are many different ways of writing code, and that are all equally okay, as long as you're consistent. Then JSHint is a slightly better option because it's less strict about the coding style. It does check everything else that JSLint does, but gives you the control over the coding style. Let me show you this in practice. Here's the code. This is the function that we saw earlier, the one that we know that doesn't work properly. We know that because of the properties of closures, overall, this code doesn't look too bad though. Nobody's seeing ever errors with it, other than the fact that it's got this, other than that it's got this function that's been created inside the loop. There's still one syntax error in there. Anyone see it? No? Really? Semicolon. The hint. No? Yeah.
line 7?
Yep, line 7. End of line 7 should be a semicolon. You've declared a variable essentially. So the declaration starting on line 4. Is it line 7? Yeah. Yeah, 1, 2. It is 7. It just doesn't look very. It doesn't look very lined up from down here. Where you say node value.onClick equals function, that equals the function statement. You have to end that statement in a semicolon, even though you're creating a function and you open a new scope. So there should be at the end of it, right there should be a semicolon. That was quite difficult for us to see there, wasn't it? Just looking at the code and stuff.
I was going to say, arguably you could replace the bar with a left.
Potentially. Yeah. Right, what was I going to show you? Okay, so let's take this code. We saw how long it took us in the class to see the problems with it. Let's just go and there anyway. Let's just bung it into not going to read that. Into JSHint, which really doesn't like being kind of which is a pain. I know you can't read it, but I've put the code on the left hand side. On the right hand side you've got the errors. There are two warnings in this generated by JSHint. First one says don't make functions with an loop. Well, that's that problem we saw before about creating functions and the closure scope being wrong. But it's telling us about that. It's also telling us that there's a missing semicolon on line 7. So this tool will automatically do that for you. Just for fun. Let's put the same code into JSLib, see what it says. First of all, it says use spaces, not tabs. Well, I'm sorry, I want to use tabs. As long as I'm consistent, it's fine. It's got a number of other errors. It says things like, so a lot of these are kind of run-on errors. So it's found an error and doesn't quite know what to do, and it's now complaining about something else. It doesn't like you using var inside a for loop like that. Actually, if you're Douglas Crockford, you were quite clearly a very old school C programmer. Back when, probably back in the 80s, back when in the original C standard, you had to declare all of your variables at the very top of the function. It's only modern variants of C that let you declare variables anywhere you like. Back in the old days, everything went to the function. And that's kind of the Douglas Crockford way of doing JavaScript. All your var declarations are on the first line after you start your function. So that's one of the errors that we've picked out. Interestingly, at the moment, it's not complaining actually about the fact that we're creating a function inside of a loop. If we fix all of the other errors, it would. But you can kind of get the you get the feel for quite how finicky it is about the programming setup. Anyway, let's see the slides. So the point of the course there, use JSHint, okay? So that's what I'll be using to check the course work automatically. We'll look at it as well. We'll use JSHint to check that the code is actually correct. Syntax is correct. You don't have to copy and paste the code into a web page. You can download it as a node module that you run on command line. You can just say JSHint, code, and it gives you a report automatically. I didn't really mention JS Check, but if you use it, you can use it as an extra tool. Use it with JS and JSLint, it takes up a few extra things. It's just quite a nice additional check. Okay, so key points to bear in mind, just to summarise. Choose a coding style. Stick to it. I don't really care what that coding style is. I don't really mind whether you use capital spaces, but just be consistent. Always write some comments, but in particular, always in JavaScript, write comments for every function and say what the parameters are, say what the types of the parameters are. Otherwise, someone else will try using it and it will break in interesting ways. Always use something like JSHIP or JSLint or one of the other tools to check for coding problems. These tools are great at finding things like implicit variables, mechanical elements, etc. All things that can cause your code to work in new and exciting ways. Okay, so I think that's about what I wanted to say today. Are there any questions? No? Okay, so next week, the sort of current plan is that on Tuesday we'll do a bit more JavaScript. Normally in this module we get a guest lecture from someone who works in IBM Cloud Services Division to come say about cloud computing. Unfortunately, I'm not quite sure where he's going to do it this year, so if he can't do it, I will magic up a lecture on cloud services. I haven't written it yet, so we'll sort something out. 1 week today, we're going to set the coursework. So the lecture which today will look at a little bit at Node.js and Heroku, and then we'll set a coursework for you to do using those tools. I'll tell you about the coursework.